guys, welcome once more to our YouTube channel. So today we are going to be looking at Cameroon National Medical Entrance Examination, Faculty of Health Sciences, FHS Boya Physics 2021 Part 2. Alright, let's get Friday. Alright guys, so the resulting force exerted on the mass solid of 5 tons is that the center of gravity of this solid moves with an acceleration of magnitude. Alright, so we basically, that's just an application of Newton's second law, right? So summation F equals to ma, so we have acceleration to be that. So acceleration is 8 meters per second squared, so our answer is A. Two marbles B1 and B2 steel balls can fall from the same horizontal plane of height 25 meters to the ground. At the initial moment, B1 is released without speed, while B2 is launched with a horizontal speed of 5 meters per second. At time t equals to 1.5 seconds, and then you have these options. Alright, so we are just going to look at what's happening. So we have the equation of motion that governs this particular motion. So we have s equals to ut plus half gt squared. So because I look at the options here, they're mostly talking about the vertical heights of those various of the various marbles. We can actually say of course h is, now if we want to study the vertical displacement of each of those particles, these marbles b1 and b2, we have to of course apply this equation of motion in that particular direction, in the y direction, right? So we actually have sy, which is basically just h, equals uy, but the uy, since b1 is actually released and b2 is projected horizontally, it means that both of them have initial vertical velocity to be 0, right? So this term actually gets like absorbed, right? So we are left with half gt squared. So we actually have h equals to half gt squared. So this particular equation, h equals to half gt squared, now governs the vertical displacement of both marbles, right? So after 1.5 seconds, so you notice that g is common, is the same for the two of them, and t is the same for the two of them because 1.5 seconds later, so they both have the same vertical displacement, right? So our answer is actually C. Alright, so a ball is thrown from a point O with a horizontal velocity of that at speed inclined by an angle alpha to the horizontal by neglecting the resistance of the air and assuming that the ball is a point mass. Alright, during its movement, the acceleration vector. Alright, so you read through the options, you notice that they're basically try to study the effect of or the direction of acceleration vector relative to the path described by the projectile. So we have this parabolic path described by the projectile, right? So we notice that if we go over to a point here where there's this slight dot on the path, we can actually look at what's happening with the velocity. So we actually have the horizontal velocity Vx, and then we have the vertical velocity Vy. So the components of the velocity v. So you notice that this velocity itself, this speed v, is actually tangential to the path described by this projectile. Now, because it's actually tangential at this very point like that, this v is actually parallel to this path at this particular point, right? Because the gradient of this curve at that particular point is equals to the gradient of the tangent to that curve at that point. Good. So our v and the path described by this projectile are parallel. Now, but I need you to know that Vy and Vx are neither perpendicular or parallel to V, right? So but we know that Vy and the acceleration acting on this particle, which is basically acceleration due to gravity, right? Because that's what a projectile is. Projectile is any particle that's given an initial impulse and then allowed to move under the influence of gravity alone. So you notice that Vy is actually in the direction of gravity, right, or the acceleration of the body. So because Vy is in the direction of acceleration of the body and Vy is neither perpendicular or parallel to V, therefore Vy is actually neither perpendicular nor parallel to the path described by the projectile, which therefore means that the acceleration is neither perpendicular nor parallel to the path described by the. Alright, so therefore options A, B, C are off, and then D actually says change direction at the top of the trajectory. Well, you actually know that the acceleration that's acting on this particle, it has a unique direction, which is A, downwards, right? So that's the direction of the acceleration that's acting on this particle. So we actually notice that E says none of the above. What? Okay, this is just supposed to be none of the above. I think there is a mistake. I typed in trajectories there. Sorry, really sorry. All right, so yeah, so answer, the best answer here is actually E, right? Because of course you know that the direction of the acceleration is actually always vertically downward, right? Good, that's what the projectile is. So our answer there is E. At the top of the trajectory, the speed is, all right, so we actually have the speed at every given point to be vx squared plus vy squared, right? The x component of the speed squared plus the y component of the speed squared. So at the top, so at any, well, hold up, at every given point, so that vx, the horizontal component of the speed, does not change, right? It's the same as ux, which is the same as u cos theta. Sorry that the angle is actually alpha. I'm using theta here, but you get the point. So we actually, and the initial velocity is v0, but I'm using u. All right, so I'm just changing a lot of things. Well, it's MCQ, so you're just doing the things based on what you are versed with doing, right? So you're versed with calling initial velocity u and not v0. So you can go ahead and do it like this and then pick up the answer in the MCQ. You must not use the v0 they're giving you, right? Because after all, you're versed with using u. All right, so we have u squared cos squared theta plus vy squared. Now, this is the speed of the particle at every given point along that parabolic path. Now, you notice that because the speed is actually going to be the square root of sum of the squares of two independent speeds, it's actually going to be minimum if any of those speeds is actually 0. Yeah, so at the top of that parabolic path, you notice that vy is actually 0, and then you just left with just one component of the speed, which is basically just the horizontal, which gives you the speed of that particle to just basically be equal to the horizontal component of its initial velocity. Therefore, at the maximum height, the speed of the projectile is at its minimum possible value, right? Good. So we actually have u cos theta, which is just the minimum value of v. So our answer is C. Okay, we have the height of the trajectory at the top is, all right, so we actually have height to be u squared sine squared theta or alpha over 2g, right? So we actually have independent of u, all right, so because I'm using u here to be visible, so independent of u, that's not true. Independent of the angle alpha, that's not true. Conversely proportional to v0, that's not true. Proportional to the square of v0, correct, right? Because v0 here is u, so that h here, the height of the trajectory, is actually proportional to the square of the initial velocity. So our answer is D. All right, the duration of the movement of the ball is, all right, so that duration is basically talking about time of flight. So we have 2u sine theta sine alpha over g. So we actually have that to be E, right? Because you go through this, you'll notice that there's actually none of these guys that correspond to this expression. So our answer is E. All right, so a star with a mass twice that of the sun has a gravitational field of that. Given mass of the sun is this, the gravitational constant that, the radius of the star is. All right, so the field intensity at the surface is just basically gm over r squared, right? So we make radius the subject, so we actually have gm over g there. So radius is actually universal gravitational constant. The mass of the star is actually 2 times that of the sun. So we divide that by g at the surface, so our radius is 10 kilometers. So our answer is C. All right, the magnitude of the gravitational field due to a solid of mass that at a point located at that is, all right, so you notice that every mass is able to create around it a gravitational field, right, with a certain gravitational field intensity that varies with distance away from that point mass. So we're actually going to assume that this our guy here is a point mass, all right? So we're actually going to say that, all right, g equals to gm over d squared, where this is basically the distance from the point mass. All right, so if it's not a point mass, then you have to talk about from the center of the earth, for instance, because the earth is not a point mass, so you have to take that distance from its center. Okay, all right, so we're actually going to use that, and then we are going to say, all right, so the distance from the point mass, from our point mass all the way to the point, is actually this. So we put in there, we simplify, and then we have our g to be 3.3 times 10 to the power negative 5. So our answer is B. All right, guys, thank you so much for watching our video. We hope you enjoyed it. Anything you want to recommend, leave as a comment in the comment section below. All right, so this is really what we want to do with YouTube, and if you want to contact us on WhatsApp or through email, just shoot right here. Thank you so much. Have a lovely time, and remember to always stay curious. Goodbye.